Hey there, welcome to this new section where we are going to learn all about linked list. But before starting our adventures with linked list, I would like to tell you about the drawbacks of arrays, and that is important. We have used arrays in many of our C programs by now. Also, we have used arrays to build our stack and queues, however, have not understood when and how the things are wrong with arrays. We need to understand that before we start our study with linked list. Actually, the drawbacks of arrays are removed with linked list. However, at a cost of sacrificing the benefits of having an array. And that is tricky, and you need to understand how that happens actually. Okay, let's go ahead and first of all try to understand what are the drawbacks of having an array as a data structure. The first problem with the array is the size of the array. We always need to mention the size of the array when we allocate them. Even when we use the dynamic memory allocation technique, such as a malloc function call, we need to mention the number of bytes for the array. And this size sometimes becomes a constraint for the program. Say your program allocates an array with 100 elements dynamically and ended up using all the elements in runtime and requires some more space to store data for the need of the current processing task. As a programmer, you need to foresee this kind of situation and would require to write code to handle such a situation. The handling code would not only reallocate the array, but also would require to copy all the existing elements into the newly allocated space, and then it would require to deallocate the existing space as well. All these activities will definitely make your code more complex, and the worst is, continuous allocation, deallocation, and copying of existing data into another location will have a bad impact on the performance of your program. The main point is, once allocated with a size, it is hazard to change the size of an array if required to do so in runtime. The second issue is performing the insertion and deletion operation at any point between the first and the last existing elements of the array. Let me just explain this with an example. Let us take this example. I have taken that array with size 10 elements there, and I have placed some values there from index 0 to 5, as you can see there on the screen. Now, if you need to delete an element in between the first and the last element, that means in between the 0th and the 5th index of the array, then how you can do that, how you can perform that. Say I need to delete that 13 at index 1 from this array. Then what you need to do is to shift all the elements from index 2 to index 5, one element towards its left, right? That means the 7 has to be shifted here in the place of 13, and then this 5 has to be shifted from index 3 to index 2, and you need to do down up to the index 5, right? So all the elements from index 2 to index 5 has to be shifted one element to its left, and that's going to take considerable amount of time. You would require to run a loop for this purpose, and consider a situation where there are a huge number of elements in the array. Now, if there are only some 10, 20, 50, 100 elements in the array, it's not going to have any impact on the performance. But if there are, say, lakhs of elements in the array and you need to delete an element in between, then there may be huge amount of shiftings, and that's going to impact on the performance considerably. So that's one problem. Now think reversely. You need to insert an element into the array. Now let us consider the other situation where you need to insert a new element at any point between the first and the last element. Say you need to insert a new element at index 2, keeping all the existing elements intact. So what you need to do in that case, you need to just shift each element starting from this index 5 up to this index 2 towards its right, one element towards its right. That means this 17 has to be shifted here, and then 8 has to be shifted here, this 5 has to be shifted here, then you need to shift this 7 here at index 3, then you can make a room for the new element that you want to insert at index 2. In order to facilitate such kind of shifting, you need to write a loop again. And if the number of elements in the array are huge and you want to insert at any point between the first and the last element, then obviously this kind of shifting is going to take huge amount of time, because the loop is going to iterate many times in order to make a room for the new element there. So The problem with the array is that if you want to have frequent insertion and deletion in between the first and the last element, that means at any point between the first and the last element, then it may have an impact on the performance of the program, because we would require to run a loop for that purpose, and huge number of elements will actually make the loop to run more number of times, and that will take more time there. In the worst case, you may require to delete the first element of the array, and in that case you would require to shift all the elements, all the n-1 elements, where n is the number of elements in the array, towards its left. And if n is large, consider a situation where you are having huge elements in the array, and that is so practical in the real life. So in that case, in such a case, your program is going to shift all those n-1 elements towards its left, and that's going to take huge amount of time. And the thing is same with the insertion. If I want to insert in the worst case at index 0, then it would require to shift all these elements, existing elements, towards its right. So these are really bad situations that we need to avoid. So if we need to perform frequent insertion deletion in between of the existing elements, then array is just not the suitable data structure for our requirements. In all such situations, we need a linked list. We'll see that with a linked list, the situation is going to be much more flexible as far as the insertion and deletion is concerned in between the elements. That is much more smart, flexible, and the time requirement will be constant in that situation. That means irrespective of number of existing elements in the linked list, it will always take the constant amount of time to insert and delete at any point in between the first and the last element. That's the benefit of linked list. And also, linked list is a dynamic data structure. That means we are going to add the elements, that means each and every element, as and when required basis in linked list. When you need an element, you allocate the element and you add the element into the linked list. You do not need to allocate the linked list at the very beginning with a predefined size like array. We'll go on adding one after another element as and when required basis when we build a linked list. We'll see all these things in the coming lectures. Stay tuned.